Your facility is wasting somewhere between 20 and 30% of its energy right now, and the systems you have in place today cannot see it. Today, we're decoding AI-driven energy management and predictive analytics. By the end of this episode, you will know exactly what these systems do, whether the ROI claims actually hold up, and what to ask your vendor before you sign anything. I am Daniel Burke, and this is Energy Answers, brought to you by Tactical Energy Group. If your electric bill is 5, 6, or 7 figures, this episode is for you. So here's the short version. AI-driven energy management combines IoT sensors. IoT stands for Internet of Things, machine learning, and real-time analytics to continuously monitor your facility's energy consumption, detect waste as it happens, and automatically optimize when and how your equipment uses power. That means it is finding inefficiencies your annual audit will never catch and acting on them before they compound into another bad bill. The question for your operation is whether your current tools are fast enough to stop the bleeding, or whether you are always reacting to a problem that already cost you money. If you've not watched episode 1 on demand charges, go back and watch it, because a lot of what AI energy management is doing under the hood is aggressively targeting those exact charges. And if you watched episode 11 on peak shaving, what we're talking about today is essentially peak shaving on autopilot with predictive intelligence layered on top. So the core decision here is this: you have equipment, you have a production schedule, and you have a utility bill. The question is whether you have the visibility to know what is actually driving that bill at the asset level in real time before it's too late to do anything about it. So what's the actual problem with traditional energy management solutions? Spreadsheets and hard-coded building management systems were built for a different operational reality. They react to monthly utility bills, they run on annual audits, and they cannot detect a motor running 15% below efficiency. They can't predict tomorrow's consumption based on your production schedule. Always working from old data on a problem that's happening right now. Now, how does AI energy management actually work? Oxmate describes a 4-stage workflow. First, data collection. IoT sensors capture consumption for every machine, HVAC zone, lighting circuit, and production line at sub-second intervals. Second, pattern analysis. Machine learning correlates energy use with your production schedule, with weather conditions and equipment status to build a baseline. Third, anomaly detection. The system flags equipment malfunctions, phantom loads, and inefficient processes within minutes, not months. Fourth, predictive optimization. The system forecasts demand, recommends operating parameters, and schedules energy-intensive tasks during off-peak hours automatically. The last stage connects directly to what we covered in episode 2 on time of use rates. AI energy management does that load shifting analysis and execution for you continuously around the clock. So what does AI catch that nothing else does? Equipment running during idle periods, compressed air leaks, HVAC system overcooling empty spaces, motors operating below optimal efficiency, phantom loads from standby equipment. One manufacturer in Oxmate's published material found a faulty industrial kitchen, adding to their costs until AI detected the overheating stovetops. For hospitals and critical facilities, clear result documents AI flagging chiller plant performance degradation before a breakdown occurs. That is predictive maintenance framed through the cost lens, not just the equipment failure lens. Now, do the numbers hold up? Oxmate, a vendor in this space, publishes the following benchmarks. Take them as directional rather than independently audited figures, and demand the underlying case data from any vendor quoting similar numbers to you. Their published figures: 15 to 20% average reduction in baseline power consumption, 11-month typical payback period in manufacturing, 99% anomaly detection accuracy within 1 day of operation, 25% maintenance cost reduction, and 70% of facilities reporting ROI above 10%. On the platform side, C3 AI claims energy cost reduction of up to 4% and time to action improvements of up to 90%. Those are vendor claims, and you should ask any vendor you evaluate to show you documented results from facilities with a similar rate structure and production profile. ABB, for its part, puts the potential savings for an AI-centric power plant at 1 million to 5 million annually per gigawatt of capacity. One more thing before you talk to a vendor. Data quality is a foundational prerequisite. ABB states directly that data cleansing, anomaly removal, and proper result interpretation are as important as ever. The system is only as good as the data fed into it, and for regulated facilities, hospitals, municipalities, one of the most important questions you can ask a vendor is which decisions the system executes automatically versus which require human approval, human in the loop. Get that answer in writing. It matters for liability, for change management, and for regulatory environments those facilities might operate in. So here's where I land on this. Oxmate puts the waste figure at 20 to 30% for facilities running on annual audits and reactive billing. Whether your facility is at 5% or 25% depends on your equipment age, load profile, existing controls. But almost every facility running on annual audits has waste it cannot see at the meter level. And if energy is 15 to 25% of your total operating expense and you have limited visibility below the meter level, you are making budget decisions with a blindfold on. The AI paradox, though, is worth naming and talking about honestly. AI data centers are themselves significant energy consumers. When a vendor tells you this technology will solve your energy problem, it's a fair question to ask how much energy their platform consumes and whether that sits in the ROI model. That's not a reason to walk away, but it is a reason to ask the question. Any vendor who can't answer it clearly, well, it's telling you something about how they'll handle the rest of your data, too. The implementation path is less disruptive than most operators expect. You start with existing utility meters. Most platforms integrate with existing SCADA, MES, and building management systems. C3 AI's published deployment claim is days to initial deployment and scale across sites within 6 months, but integration with some legacy SCADA, MES and BMS is where most projects end up slipping. So you've got a budget for that, and those timelines can really extend. I'm going to pull this all together for you. AI-driven energy management produces real results when you have meaningful energy spend, limited asset level visibility, and equipment running around the clock. The ROI case has real supporting data behind it. The payback benchmarks in manufacturing point to under a year, and the specific inefficiencies these systems surface, phantom loads, motor degradation, HVAC waste, are exactly the kinds of waste that never show up on a utility bill audit. It's already costs you at that point. Now, it creates exposure when you skip the data quality work, when you assume the system runs without human oversight, or when you sign a contract before confirming it integrates with your existing infrastructure. Now, I don't run your facility. That's your job. My job is to bring you definitive answers to the most pressing energy questions facing commercial and industrial operators like you. So here's the bottom line on AI-driven energy management. If your facility is spending 5 figures or more on electricity each month and your current tools give you visibility only at the meter, you're leaving real money on the table every single day. The question is not whether AI can find waste in your operation. The question is whether your data infrastructure is ready to support it. So here are some questions you can take to your team. Do you know your energy consumption at the individual asset level or only at the utility meter through their smart meter interface, which honestly is not that great? When was the last time someone in your facility identified and corrected a phantom load or a motor running below efficiency? And how long did that take? If a vendor quotes you a 15 to 20% reduction, ask them to show you a documented case study from a facility with a similar production profile, the same exact rate structure, and similar existing infrastructure, not a best case number from a green field deployment. Every vendor has their kind of cornerstone case study. You need to make sure the case study looks like what your facility actually looks like, all right? And then ask explicitly which decisions does the system execute automatically and which require human approval before the action happens. And you're going to want to get those stats, have that understanding in writing if you can. Hey, if today's episode got you thinking about an AI energy management project you have in the works or one you are planning, I want to help you. Me and the team at Tactical Energy Group created the Energy Decision Blueprint for exactly this situation. If you're an Indiana based commercial or industrial operation spending five figures or more on electricity each month, here's what we do. We get on a call, understand your situation and your project, and figure out quickly whether we can actually be helpful to you. If we can, we'll pull your bills and your interval data, review any vendor proposals or pro formas, and take it all back to our team. We'll crunch it and give you our full opinion, whether the project is optimally suited for your operation, whether the payback will actually materialize, and if the vendor's model takes your specific rate and operational realities into account. We'll also flag opportunities you may not have considered. Now you'll get the write up, and we'll go over it on a follow up call, and you're obligated to nothing. If that process interests you, click the link in the description below or go to tacticalenergygroup.com and look for Energy Decision Blueprint. Hey, thank you for listening to Energy Answers, brought to you by Tactical Energy Group. If this helped, send it to another operator you know who's dealing with the same headache, and visit tacticalenergygroup.com to get more practical tools for your facilities.